Hello guys, so welcome to our channel, Raw and Basic. So in this video, we will learn about the intercepts and zeros of your rational functions. So reviewing your rational functions, these are the functions in the form of r of x over cube x, assuming your numerator is denoted by r of x and your cube x is your denominator. And the condition is the cube x should not be equal to 0, or a rational function is a ratio between two polynomials. Your numerator is a polynomial as well as your denominator, where your denominator should not be a 0 function or should not be equal to 0. Because in this case, when your denominator is 0, the function will be undefined. Okay, so let's go to your intercepts, zeros of rational functions. So first, let us define your intercepts. Okay, so we have two intercepts, your x-intercept and your y-intercept. So by definition, intercepts are the point or points of intersection of a graph or curve or maybe a line to x and or y axis. So in this case, I will give you a visual presentation of an example of a rational function and its graph and where to find its y and x intercept. So before that, let us define your x-intercept. Okay, so x and y intercepts are the intercepts under your concept of intercepts, of course. So x-intercept is the point of intersection of a graph to the x-axis, while your y-intercept is the point of intersection of a graph or curve in your y-axis, of course. So in this figure or graph, assuming this is the graph of a common or certain rational function, and just focus in here. So on this part, you can see the curve or the graph intersect your axis. So we have your y-axis and we have your x-axis, of course, the horizontal. So in this part, in our y-axis, your curve or your graph intersect. Okay, so this is your y-intercept, the intersection of the graph or curve on your y-axis. And this point or coordinate has an ordered pair of x and 0. So this point has an ordered pair of 0 and y, or in some books you have there 0 and b, or to be basic, let's use 0 and y. So I will explain it later. Then here for your x-intercept, of course, this point has also a coordinate or ordered pair of x and 0. So if you can see on actual example, this one example, we have 1, 2, of course this is 3. So this point has coordinate of 3 and 0. Okay, 3 and 0 because it is on the x-axis. While this one, its coordinate is 0 and let's say 1 and 2. So 2. Okay? So as a basic concept of your y-intercept and x-intercept, so you can solve your x-intercept when y is equal to 0. Okay? Your y is equal to 0 because every point has a coordinate of xy. So we have x, we have 3, and your y is 0. And going to your y-intercept, we can solve your y-intercept when the value of x is equal to 0. Okay? So what about your zeros? So the zeros of the function will focus on your x-intercept. So on our graph here, so the zero of the function here is 3. Okay? 0 of the function is 3, but the x-intercept is at 3, 0. Okay? So I guess you can see the difference between x-intercept and the 0 of the function. Some books, zeros of the function is also known as the root of the function or the root of the equation. Okay, so let us now proceed to computing or solving your intercepts and zeros of rational functions. Okay, now let us proceed to computing the intercepts and zeros of your rational functions. So on the board we have here two functions or two rational functions. We have f of x and g of x. Okay, so let us try to solve number 1. So let us not forget that any function, such as functions denoted by f of x, can be also in the form of y equals to 3 over x, 3 minus x I mean, over x plus 1. Okay, again, f of x is your y, or f of x is equal to y. Can be g of x equal to y. Okay, so let us continue. So first, let us try to solve for your x-intercept. So your x-intercept, again, by concept, x-intercept, by concept and definition, can be solved when y is equal to 0. So that is the reason why we can make f of x equal to y. For us to solve y equals 0, because on this form, some of us will ask, where is y in there? So f of x is your y. Okay? So let us use y equals to 3 minus x over x plus 1. Substitute y equal to 0. So we have 0 equals, okay, following, we have 3 minus x over x plus 1. Okay, by cross multiplication, we have equals in here. So we have 0 times x plus 1. Cross multiply. Then copy 3 minus x. Okay, in here, any number or any quantity multiplied to 0 is 0. That is the 0 property of multiplication. So any number multiplied to 0 is 0. So we have 0 equals 3 minus x. Then by addition property of equality, we have plus x, so we have x equals to 3. Or you can hear some of your teachers will say, transpose negative x on the other side. But again, transposition is not an operation for equations and inequality. The basic operation in here or property is addition property of equality. So we added x to cancel x or eliminate x on the other side. And your equal symbol denotes balance. So if you will add x in here, you will add x in here. So we have your x in here, and then minus x plus x, x will be eliminated. So we have a remaining of 3. Okay? So that is the most basic and fundamental concept behind it. So we have your x equal to 3. So x equal to 3 means that your x-intercept is at point 3 and 0. okay, at point 3 and 0. Then the zero of the function is 3. Okay? So the root of the function is 3, but your x-intercept is at point 3, 0. Okay? Before we proceed to solving your y-intercept, let us go back on our solution or procedure in solving your x-intercept. I will give you some hint on how to make it more shortcut. So here, we have here your denominator cross multiplied to 0, and then your denominator becomes 0. So in this case, or part of your solution, we can say that in solving your x-intercept, we are just solving for the 0 of the numerator. Okay, so we will focus on your numerator. So our numerator is 3. Our numerator is 3 minus x. Okay? Then equate it to 0. Then solve for x. So isolating x, we have negative x. Then we have 0. Then negative 3. Or, by common sense, we have negative x and negative 3. Okay, so we are not solving for the negative value of x. We are solving for x. It means that we are solving for the positive x. And because of that, we will multiply negative 1 to your whole equation. So we have x equal to negative 3. Okay? So in case that it will be comfortable for you to solve using your numerator against this one, so for me, it is the easiest and the shortest way to solve for your x-intercept of rational functions using your numerator. Okay? Okay, so let us now solve your y-intercept. So your y-intercept can be solved when x is equal to 0. So we have here y equals, copy your rational function 3 minus x over x plus 1. Then substituting 0 as a value of x to your function. So we have y equals 3 minus, so again the value of x is 0. Then the value of x is 0 plus 1. Okay, therefore y is equal to 3 divided by 1. 3 divided by 1. So therefore y is equal to 3. Okay? So in summary, we can say that your x-intercept is at point 3, 0. Okay? Your y-intercept is at point 0 and 3. Okay? So if we can present it graphically, or if you can encode it on some graphical calculators such as Algebra or Desmos. Okay, you can install this scientific calculator or graphing calculator in your phones, so you can see some visual or graphical presentation of functions. So, giving you a hint of the graph of this function, it will be just like this one. So the x and y intercept there. So this is your x-intercept, assuming so you have your 3 and 0, and your y-intercept will be 0, 3. Okay? So I guess you visualize the concept and understand the concept behind the graph as well as the intercepts and zeros of this given rational function. So now let us proceed to the next example. Example number 2, we have g of x here. So we have g of x equals to x squared minus 3x plus 2 over x squared minus 4. So again, let's put your function in the form of y. So copying x squared minus 3x plus 2 over x squared minus 4. Okay, so if you can see your function is in quadratic form or quadratic degree. So when your function is at quadratic degree, as well as your numerator and denominator, it will be a hint for you that it can be factored. But in some cases, it cannot be. But on this example, let us assume that your numerator and denominator can be factored. So before we can solve for the x and y intercept, let us simplify your given rational function. So in here, let us simplify y is equal to x squared minus 3x plus 2 over x squared minus 4. So this is a trinomial. So a trinomial has a factor of 2 binomials. If you can see your denominator is a difference of 2 squares. So your first term is perfect square as well as your second term. Okay, so given that, we can factor your numerator as well your denominator. So the factor of x squared is x times x, of course. Okay, so what are the factor of positive 2? So positive 2 is equal to 2 times 1. Okay? So 2 times 1. Then the sign. So how can you be sure that the factor 2 and 1 will be the factor in here? Because when you add 2 and 1, it will be 3. And 3 is your middle term or the numerical coefficient of the middle term. But here you can see the negative sign. So if that is a negative, we will put both negative. Okay, multiplying negative times negative is positive. Negative plus negative is negative. 2 and 1 is 3. Okay, so I guess that we are clear in that. Let us proceed to your denominator. So the factors of your denominator are x times x, the first term. Then your, do you call this your difference of 2 squares? Always follow this form. We have plus minus, or you can put minus and plus in here. Then the factors of 4 are 2 and 2. So positive 2 times negative 2 is negative 4. Okay, so if you can see, we have 2 terms because if you are on the full method, the middle term will become 0. This one. So 2x plus negative 2x is 0. Therefore, the middle term will be eliminated. So we are on a factored form and we can simplify your given rational function easily. Just look at if there are common factors between your numerator and denominator. So in this case, the common is x minus 2 and x minus 2 on your denominator. So dividing it, it's just like this one. Okay, I will give you some analogy. So example, we have 2 times, okay, this one. 6 over 8. In factored form, you have your 2 times 3 and 2 times 4, just like that. Okay, 2 divided by 2 is 1, or it will be eliminated, so you have your 3/4. Okay, so just like this one, we are simplifying your rational function or your fraction into the simplest or the lowest term. Okay? Okay, so let's go back. So the remaining term for your numerator will be x minus 1 and the denominator is x plus 2. So therefore, we will use this rational function to solve for your x-intercept. So solving your x-intercept, so y will be equal to 0, but again, we will be using your numerator to make it more simpler. So identify your numerator. So your numerator will be x minus 1. Then equate it to 0. Simple as that. So x is equal to positive 1. So therefore, your x-intercept will be at point 1 and 0. Okay? And the 0 of the function is 1. Okay, so this will be your x-intercept. This is your 0. Okay, let us proceed to your y-intercept. Solving your y-intercept is giving the value of x equal to 0, or it's just like you are solving for f of 0. If you will go back to g of x or f of x form. Okay? So we have y equals to x minus 1 over x plus 2. Then substitute x is 0. So guys, if you can see, we are eliminating x as a variable because x is 0. So x will be eliminated. So by common sense, if you would just cover your x or simply eliminate your x right away, you will have the value of negative 1 plus negative 1 over 2. So writing it, you have an x-intercept or y-intercept, plus 2 1/2. Okay? This is your x. So again, y is equal to x is 0 minus 1, 0 plus 2. So x was eliminated. Or just cover your x. The remaining will be negative 1. Negative 1. So you will be asking, where is the correct form of writing the negative number? Either in the numerator or in the denominator, or the most correct way is writing it on this one. Okay? So we are writing your negative sign at the center of your equal symbol, integral, or in line with your fraction bar, because a number divided by a number. So negative divided by positive is negative, or it is accepted to write your negative or minus sign on the numerator. Okay? So your y-intercept is at point x is 0, y is negative 1/2. So if you will have a graph of this, using again the suggested app on your phone, the graph will be just like this one. So it will be your y-intercept and x-intercept. Okay? So your x-intercept will be at 1 and 0, while your y-intercept in here will be at 0 and negative 1/2. So I guess we are clear on this example. Let us proceed to another example to make you more clear on this concept. Okay, so let us have another example of computing your x and y intercepts and zeros of your rational function. So on the board you have a function h of x equals to x minus 3 over x squared minus 9. So let us put it in the form of y equal to x minus 3 over x squared minus 9. So again, if you can see, your denominator is at the quadratic degree. So when you are on a degree greater than 1, you can assume that your terms, whether your numerator or denominator are or is, can be factored. So let us try to look your denominator. So the denominator is x squared minus 9. So if you can see, your denominator is a difference of 2 squares again. So let us simplify it by factoring your denominator. So we have your numerator x minus 3, and then your denominator in factored form is x plus 3 times x minus 3. Or you can put minus 3 in here and plus 3 in here. It will be the same. Okay? Okay. So simplifying your given rational function, the common is x minus 3 and x minus 3. So what will be the remaining quantity above if you will get this x minus 3? So always put in mind that there is a factor 1. Okay. And then x plus 3 on your denominator. I will give you an example. Example, you have this one. 2 over 4. In factored form, the factor of 2 is 2 times 1. Okay? And the factor of 4 is 2 times 2. So what is the common? Common is 2. Then we have 1 half as a simplified form of 2 over 4. So you will be asking, where did we get this 1 on your numerator? So x minus 3 has a factor of 1 there. But it's understood that there is 1 in there. So it will be ugly to put quantity times 1 there. But I guess you understand the concept behind it. So let us use this rational function. So we have y equals to 1 over x plus 3. So now let us solve for your x-intercept. So your x-intercept, y will be equal to 0, or we will be using your numerator. So identify your numerator. Your numerator is 1. Equate it to 0. 1 equals to 0 is a false statement. You cannot solve for x in here because you can see your numerator has no x in there. So it will be a false statement, or assuming this is an error. Okay, so I will explain it to you why it become an error or a false statement on your x-intercept. Okay, not all functions intersect at your x-axis. So some function, example, you have this graph, some function will not intersect in there in your x-axis. So assuming this is your x-axis, of course. So some graph will not intersect in there. Okay? Some will just like that. Or assuming we are not on rational function, some graph are here. So there is no intersection on your x-axis. Okay? So that is why we cannot solve for your x-intercept, because some graph or graphs of your rational functions will not intersect, touches, or cross your x-axis. So let us proceed to your y-intercept. So we can say that there is no zero in the function. Or we can say that the graph never touches nor intersect x-axis. Okay, so I guess we are clear on your x-intercept, why we cannot solve for your x-intercept. So let us proceed to your y-intercept. X is equal to 0. So again, just cover your x because x will be eliminated. Well, the value is 0. So covering your x, you can solve your y-intercept right away. So y is equal to y over x plus 3. So we can solve it as y equal to 1/3. Okay? If we are on the hurry. But let us solve y is equal to 1 over 0 plus 3. Okay? So y is 1/3. So we can say that the graph will intersect your y-axis at point 0 and 1/3. Okay? Again, your graph will cross your y-axis at the point 0 and 1/3. Or you will try to look at your graphical calculator. The graph will look like this. Okay? And this. So it will not cross your x-axis, but it will cross your y-axis at point 0 and 1/3. Why your graph do not cross your x-axis? So it will be our next topic. So the graph cannot cross the x-axis because the x-axis will be its asymptote. So it will be discussed on the next video. So I guess you have learned on our class or video this time. So please subscribe and watch. Thank you so much and stay safe.